Hey there, this is Divya from Chalkboard Academy and welcome to Class 10 Mathematics series, and in this lecture we will be discussing chapter 3, that is pair of linear equations in two variables. So let's start with the topics first, what we are going to discuss in this chapter. So the very first topic we will be discussing here is that pair of linear equations in two variables. We have already discussed linear equations in earlier chapter. Now we are going to discuss pair of linear equations in two variables. First we will understand what is a linear equation in two variables, and thereafter we will talk about the pair of linear equations, that is two equations simultaneously. And then when we are talking about two equations, we will be discussing about the solutions. Here we will have three type of solutions, like unique solution, mini solution and no solution, depending upon the common solution we get in these two equations. If these two equations have one common solution, then we say that unique solution, and if they do have more than one solution, then we say many solution, and if they do not have any common solution, then we say no solution. Thereafter we have graphical method. Here we will see the relation between these two equations and how they have either they are consistent to each other or inconsistent to each other. Then we have algebraic method to find out the solutions of these equations. Here we have three methods. First one is substitution, second one is elimination, and the third one is cross multiplication. Moving forward, let's start with the first topic. So the very first topic we are discussing here is linear equations in two variables. Here, first understand what is a linear equation. So in linear equation, we are talking about that they do have degree 1. So linear equation has degree 1. And when we are talking about the two variables, then they are having more than one variable. Here in this general form, we see here ax plus by plus c is equal to 0. Here we have two variables, that is x, and another one is y. Now we have three constants here, that is a, b and c. Out of these three, we are supposed to have a and b that shouldn't be 0. Why? Because if a is 0, then the equation becomes one variable. When b is 0, again it becomes a linear equation in one variable. So a and b cannot be 0, whereas c can be 0. Let's look into some examples to understand this clearly. So the very first example here is 2x plus 3y minus 7 is equal to 0. Here in this example, we have a, we have b and we have c. So a and b are positive numbers here, whereas c is negative. So these constants can be any number, any real number. They can be irrational number like root 3. They can be rational number like 2 by 3. They can be decimal expansion like 1.2, etc. Now we have another example here, 9x minus 2y plus 8 is equal to 0. Here we see that we have b as negative integer. Now we have third example in which we see that 5x is equal to y. Here we do not have any c. Still it is linear equation in two variables. Why? Because it is satisfying its two criteria. First, this equation has degree as 1, highest power as 1, then has two variables in it. So it is a linear equation in two variables. Then last example here, in this example we see minus 7x plus 2y plus 8 is equal to 0. In this example we have a as negative number. Now moving forward, when we are talking about pair of linear equations, so here we are going to generalize the pair of linear equations, like how we have generalized the a linear equation in two variable as ax plus by plus c. So now because we have two equations, so we have denoted them by a1, b1 and c1, and the second with a2, b2 and c2. So the first equation becomes a1x plus b1 by y plus c1 is equal to 0, and the second equation becomes a2x plus b2y plus c2 is equal to 0. Now moving forward, when we are talking about the linear equations in two variables, we have only three possibilities how these equations are related to each other. So the very first possibility is they will be intersecting to each other. Like in this diagram, we see that this is one equation, line drawn by one equation, this is second equation, and the line drawn by these two equations are intersecting, that is cutting each other at a point. So these lines are intersecting to each other. Similarly, we have second option in which we see that these two lines will not intersect each other anywhere. So they are parallel to each other because they will not intersect each other. Even if we extend these two lines far away, they will not intersect each other because they are parallel. If all the distance here, 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 at any point, the distance between these two lines are equal. Now we have third way in which we see that they are coinciding with each other. That is, the first line is superimposing the second line. In this example, we can see there is one line which is denoted by blue, and then we have another line which is denoted by red. Both are on each other. Now moving forward, let's look into the graphical method. So graphically also we can say that intersecting, parallel and coinciding lines, because on graph we are making the lines out of these equations. So let's look into example here. So first we will solve this example to draw a graph, and then in the graph we will see how this is intersecting, how they are parallel to each other, or how they are coinciding to each other. So in this example we have two equations. First is 2x plus 3y is equal to 5, and another one is x minus 2y is equal to 0. So the first equation we are solving here. So case 1, we have put the value of x is equal to 0. So by putting the value of x is equal to 0, we have calculated y. So now we have y. Now let's look into example to find out the solutions here. So the first example here is the equation we are going to discuss. To understand this more clearly, let's look into the example, and we have to draw a graph, and based on that we will be discussing further. So here two equations are given, that is 2x plus 3y is equal to 5 and x minus 2y is equal to 0. So in this we will be first solving the first equation, thereafter we will move to second equation. So the first equation here we have taken 2x plus 3y is equal to 5. The very first case we are taking here is put x is equal to 0. We have put x is equal to 0. Now the equation has only one variable, that is y. So now we are calculating the value of y, which is here 1.6. Similarly, in the second case we are taking y as 0. Now we have equation with only one variable, that is x. So now we have calculated the value of x as 2.5 here. Whenever we are supposed to find out, draw a graph, we will be taking two cases, like first case in which we will see x as 0, and the second case we will take y as 0, and the third whatever you like we can take 1, we can take -1, or we can take 2, or any other number, whatever you feel like is more suitable, and you can get the number easily, natural number or integer easily. So here we have put x as 1. So in this we see that when we have put x as 1, we get y also as 1. So let's look into the box we have created here. When we have put the value of x as 0, we got the answer as y as 1.6, and when we have put y as 0, we got x as 2.5, and when we have put x as 1, we got y as also 1. Now we have another equation. So let's look into another equation which we had in this question, and we are also solving this equation in the same way like how we did in earlier. So first part, here we will take x as 0. So again, when we have taken x as 0, here we get y also as 0. So now we cannot put second case as y is equal to 0, because when we will put y as 0, we will again get x as 0. So this is only one solution. Now for that we are going to put another number. So we have taken x as 1. When we have taken x as 1, it becomes this, y is equal to 0.5. Now third case, in third case we are going to put another number like -2, -3. Here we have taken -1. So now we have y as -0.5 here. Again, so now let's look into the box we have created here. So here, when we have put x as 0, we got y as 0. When we have put x as 1, we got y as 0.5. And when we have put x as -1, we have got y as -0.5. So solutions of a pair of equations can be of three varieties, that is unique, many, or no solution. So unique, when we are saying that they have only one common solution, many solution when they have more than one common solution, and no solution when they do not have any common solution. Moving forward, when we are talking about graph, we have two things here, that is consistent or inconsistent. So what do you mean by consistent? We say a pair of linear equations as consistent when they have at least one common solution. So when we are talking about consistent, many and unique solution containing equations are considered to be consistent to each other. And when we are talking about inconsistent, so the pair of linear equations do not have any common solution, so they are called inconsistent. So whenever in equation we find out that you are asked that tell us whether these equations are consistent or inconsistent, if they do not have any common solution, then you will say that they are inconsistent. That is, if we draw a graph and we get parallel lines, then they are inconsistent, and if we get coinciding and intersecting lines, then we say they are consistent to each other. So let's draw a graph to this. Now from those equations we have drawn this graph. Here this is the equation 1 we had used, and here this is equation 2. Now we can see that these two equations cut at some point. This point we have not found out this point on the equations when we were doing equations, but they are intersecting at this point. So they are actually intersecting lines. Moving forward, let's look into another example. Here, instead of giving equations directly, I have placed a question. So let's look into the question. Romila went to a stationery shop and purchased 2 pencils and 3 erasers for ₹9. Her friend Sonali saw the new variety of pencils and eraser with Romila, and she also bought 4 pencils and 6 erasers of same kind for ₹18. Represent this situation algebraically and graphically. So in this, first we are going to form the two equations, and thereafter we will find out the solutions. So let's begin. So the very first, let's assume the cost of one pencil be x and the cost of one pencil eraser be y. So now for first equation, that is we have 2 pencils and 3 erasers, the equation becomes 2x plus 3y is equal to 9. Similarly, we have another equation in which we have 4 pencils. So 4x plus 6y is equal to 18. Now we got two equations here, and now we are going to find out the solutions. For this, I am not going to discuss again the same way like case wise. to find out the solutions. I am directly putting this in the form of box here, the solutions here. So the first equation, for first equation I have taken 0, x as 0, then I got y as 3. When I put y as 0, I got x as 4.5, and similarly when I put y as 1, I got x as 3. In equation 2 also I have used 0 for x and then 0 for y, and I got same results. So because I am getting here, you can see here that 0 and 3 and 4.5, 0, same results here. These two equations have similar answers, so we can say that they are having many solutions. So moving forward, now we have drawn this graph, and here we can see that these two lines are coinciding to each other, and we have seen that when we are talking about coinciding lines, they have more than one solution. So by looking into the solution also, we can say that they are coinciding, and here also in the graph we can clearly see the lines, they are on each other, they are superimposing each other. Moving forward, let's look into another question. So in this we have this, we are given with these two equations and we have to draw the graph. Again in this I will not be discussing how I have found the solutions. I am directly putting them in the box what I have got here. So for equation 1 I have placed this x plus 2y minus 4 is equal to 0, and I got these three values, and similarly for 2x plus 4y minus 12 is equal to 0, for that also I have got three values, and in each case first I have taken x is equal to 0, and then I have taken y as 0, and then I have taken x as 2. Now let's look into the graph. So here I have drawn this graph, and in this graph you can clearly see they are parallel to each other. They will never intersect each other, because at any point when we are looking into the distance between these two lines, we see every point they are equal to each other, so they will never intersect each other. So here we can see that they are forming parallel lines. So by this we can say that there is a relation between these two equations, and look into the relation first. So we have first equation there as 2x plus 3y is equal to 5 and x minus 2y is equal to 0. So when we are putting them as a1 by a2, we see 2 by 1, then b1 by b2, and then c1 by c2 here. So in these we see that these ratios are not equal in first case. So we can simply say a1 by a2 is not equal to b1 by b2. When this happens, we get unique solution, as we have seen in first question, that we got intersecting lines. So these equations have this relation, a1 by a2 is not equal to b1 by b2. Similarly, we have second part here, in which we have taken about the second question. Here we got coinciding lines, coincident lines. Here we had many solutions. So here we see that the ratios are equal, like 2 by 4 is equal to 3 by 6 is equal to 9 by 18. So a1 by a2 is equal to b1 by b2 is equal to c1 by c2. We can simply see here as well that in this equation, in first equation, 2 is multiplied, then we have got this second equation. So always whole equation is multiple of another equation. So these equations are coinciding and have many solutions. Now in third part, we see that these two equations are here, in which we can see that a1 by a2, that is 1 by 2, is equal to b1 by b2, that is 2 by 4, but it is not equal to c1 by c2. So they do not have any solution because they are parallel to each other, no solution, inconsistent to each other. So these ratios, we should be aware about these ratios, because now we are going to use these ratios to find out the values. Sometimes we will be given a as k or p or any other variable which we do not know, and we have to calculate that number. We have to find out that number, and we will be finding out this by using these ratios. When we will be given that these are intersecting lines, these are inconsistent, these are consistent, and so on. So let's look into the questions here. So the first question here is on comparing the ratios, that is A1 by A2, B1 by B2 and C1 by C2, find out whether the following lines are linear equation or whether the following pair of linear equations intersect at a point or are parallel or coincident. So let's begin with the first question here. In this question, we are given with two equations, that is 5x plus minus 4y plus 8 is equal to 0, and then 7x plus 6y minus 9 is equal to 0. So for that, we are going to form the ratios. So 5 by 7 is not equal to minus 4 by 6. So here at first step they are not equal. We don't need to move to third part where we will get the ratio of C1 by C2, because A1 by A2 is not equal to B1 by B2. Then we can say that they are intersecting lines. So these are intersecting lines. That means they have unique solution. Moving forward, we have another question here in which we are given two equations. 6x minus 3y plus 10 is equal to 0. 2x minus y plus 9 is equal to 0. In this again, we will be forming the ratios. So 6 by 2, that is 3 by 1, and minus 3 by 1 is also equal to 3 by 1. So at first step we see that they are equal. That is A1 by A2 is equal to B1 by B2. So we will be moving to third part, that is on third ratio, that is C1 by C2. Either C1 by C2 is equal to them or not. So if they are equal, then we will say that coinciding, and if not, then parallel. So here we see that C1 by C2 is not equal to A1 by A2 and B1 by B2. So they are parallel lines. Similarly, let's look into the third question. Here we have these equations, 9x plus 3y plus 12 is equal to 0, and the second equation 18x plus 6y plus 24 is equal to 0. Here in this equation we can simply see that the second equation is actually the multiple of first equation. Here in second equation 2 is multiplied to the first equation, and then we have retrieved this equation. So we can see clearly that all the three ratios will be equal. So let's look into the answer. So 9 by 80, which is equal to 1 by 2, 3 by 6, which is also equal to 1 by 2, 12 by 24, which is also equal to 1 by 2. So all three ratios are equal after simplifying them. So we can say that these are coinciding lines. So they have many solutions. Moving forward, let's look into another question. In this, we are again going to compare the ratios, but here we are not supposed to find out whether they are intersecting or coinciding or parallel lines. Here we are going to find out whether these linear equations are consistent or inconsistent. So as we have seen in the table, that when these the equations are intersecting or they have many solutions, they are called consistent. So in this equation, like here, first equation 3x plus 2y is equal to 5 and 2x minus 3y is equal to 7. So when we are going to form the ratio here, we will get 3 by 2 is not equal to 2 by 3. When they are not equal, they have one solution, one unique solution here. That means these equations are consistent to each other. Now moving forward, we have another equation 2x minus 3y is equal to 8, 4x minus 6y is equal to 9. Here we will be forming ratios again. So let's look into the ratios here. So 2 by 4 is equal to minus 3 by 6, which is actually equal to 1 by 2 after simplifying. Then they are not equal to 8 by 9. When they are not equal to 8 by 9, That means they are parallel to each other, and when they are parallel, they do not have any common solution, so they are inconsistent to each other. Now we have third example here, in which 9x plus 3y plus 12 is equal to 0, 18x plus 6y plus 24 is equal to 0. This is the same example which we have done earlier in last question. So here we see that all the three ratios are equal. When all three ratios are equal, that means they are coinciding or have many solutions. That is, they are consistent to each other. So this is called, they have many solutions, so they are consistent to each other. Now moving forward, let's look into another type of question. Here we are going to find out the value of some variable which are given. Like here we are given with, for which value of a and b does the following pair of linear equation have an infinite number of solutions. That means infinite means they have many solutions. So here we are given with this first equation. First equation doesn't have any a or b here. Simple equation, 2x plus 3y is equal to 7. Now the second equation here, we see instead of any number, we get here a minus bx plus a plus by is equal to 3a plus b minus 2. Now what we are going to do, we are going to form the ratio of this, because it is given, it has infinite many solution. That means all three ratios, that is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. So we are going to do that only. So for infinite many solution, we know a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Here a is 2, b is a minus b, a1 is 2 and a2 is a minus b, b1 is 3, b2 is a plus b, and c1 is 7 and c2 is 3a plus b minus 2. So now we are just comparing, we will be using two ratios at one time, and we'll find out two equations, and thereafter we will equate them to find out the value of a. Let's see how we have done that. So here we are taking this first ratio, and then we have taken this third ratio. Now we have compared them, and directly we have done what? Cross multiplication. So after cross multiplication, 2 is multiplied to this whole denominator here, and then 7 is multiplied to a minus b here, and after solving it further, we got this as a result, minus a plus 9b is equal to 4. Similarly, now we have next part. In next part, we are comparing first two ratios, that is 2 by a minus b and 3 by a plus b. So after comparing them again, what we are doing? We are doing cross multiplication. So after cross multiplication here, we have got this as a result, minus a plus 5b is equal to 0.